Morning, children.
ठीक है सर, शेयर कर दिया हूँ। आप ये 9 नंबर पे आ गया।
Are you able to see the screen? Hello?
Good
Yes, sir.
morning, sir. Yes, sir.
You are able to see the screen. So, we are going to start in another minutes or so the first class on today, big data. Okay, another 1 minute. Let's wait. Let everybody be there. So, I'll start the class. Okay. Okay, all of you are ready?
Yes, sir.
Okay, fine. So, mining big data. So, that's the question. How do you mine? एक तो होता है माइनिंग करना, माइनिंग मिनरल जमीन से निकालना, जब डेटा को माइन करना। एक होता है माइनिंग द बिग डेटा. हाउ डू यू माइन द बिग डेटा टू गेट द रिजल्ट्स आउट ऑफ दैट? So this is introduction, objective, finding similar item, finding similar sets, Jacquard similarity of sets, documentation similarity, and all these things are being discussed here. Equivalent distance, Jacquard distance, cosine distance, edit distance, and then Hamming distance. These are the Hamming distance is the new term which you have used. Rest you all know. This, so introduction to other techniques, summary, and all that. Introduction. In the previous block, you have gone through the concept of big data and big data handling framework. So that's what you did, all the things you have done. So now some of the technique include Jacquard distances, Hamming distances, etc. And in addition, the unit also discusses finding similarity among the documents using shingles. Finally, this unit introduces you to some of the other techniques that can be used for analyzing big data. So it will come to machine learning technique, the Python programming, and all these things. So objective is explain different units, techniques for finding the similar items, explain the process of collaboration or collaborative filtering process, use shingling, find similar documents, explain various techniques to measure the distance between the two objects, define supervised and unsupervised learning. We have been talking of supervised learning and unsupervised learning for quite some time. So finding similar items, उसमें क्या है, problems definition क्या है, given an extremely large collection of item set which may have million of sets, how do you find which are similar items? So purpose of finding similar items is you may like to clarify web pages that are using similar words. So they are using web page as product or medicine. All these things are same pages, are web pages are using it all. You may like to find the purchases and feedback of customers on similar items. Okay. Another interesting use of similar item set is entity resolution, where you need to find out if it is the same person across the different areas, so that you may find one person may be leaking here, same person may be leaking at the other point also, so that you find there is a similarity between the items person is leaking, and then comes the similarity of the person there and all that. Two or more web pages amongst millions of web pages may be very similar, identical हो सकती है. जो different people have established web pages, or same person has established two web pages, one for one organization, other for other organization, but those are very similar. or the two different persons have established web page almost similar to each other. So that type of thing there. Why finding similar items is the problem? So one of the simplest way to find similar item would be to compare two documents or web pages and determine if they are identical or not by comparing sequence of characters, words and all that. तो देखना कितने कौन से वर्ड टैली करते हैं, कौन सी अगर प्रोडक्ट है वो कैसे टैली करती है. For about 10 into 6 document per web page, you need to make about 5 into 10 into 11 comparison. Thus, the question is how to find these identical documents per page, per web page. So that's also, it's a problem, but it's a problem. You have to find a solution for this. Now, first we discuss the technique for finding the similarity of sets. So finding similar sets कैसे करोगे? We discuss one of the major finding similarity among the sets is Jacquard similarity of sets. Jacquard similarity is defined in the context of sets. Consider two sets, set A and set B. Then formula लगा set A and B, cardinality of the set A or B. The value of this is A and B, A or B. So, for example, consider the set A is equal to A, B, C, D, E, and set B is equal to C, D, E, F, G. Then Jacquard similarity of the two set will be C, D, E, A, B, C, D, E, F, G. 3 by 7. Because A or B will combine everything. जो A के साथ A है, B के साथ B भी नहीं है, A भी आ गया, C इसमें C बराबर है, वो भी कहा जाएगा, D भी आ जाएगा, E भी आ जाएगा, F भी आ जाएगा, G भी आ जाएगा. लेकिन when you are talking of A and B, तो उसमें जो इसमें सिमिलर है वो नहीं आएगा, जो सेपरेट है वो आ जाएगा. जैसे A, B, C, इसमें क्या है, C, D, E आर सेपरेट, C, D, E आर सिमिलर, बाकी सारे सेपरेट है. A, B इज सेपरेट, F, G इज सेपरेट, वो नहीं आएगा. सिर्फ C, D, E, इसमें भी C, D, E है और इसमें भी C, D, E है, दोनों आ जाएगा. So this is Jacquard similarity sets become 3 by 7. You understand it? Is it okay? Yes?
Yes, sir.
Yes.
Okay. Okay. So then you can talk of document similarity similarly to check up plagiarism कि किसी रिसर्च पेपर में दूसरे के रिसर्च का तो नहीं इस्तेमाल करा होगा, या किसी प्रोडक्ट को दूसरी प्रोडक्ट को इस्तेमाल नहीं करा होगा, या किसी और इवेंट को अपना इवेंट तो नहीं बनाया हुआ. आज जो AI में बनाते हैं, शक्ल बना देते हैं, all type of thing they do it. So interesting domain use of Jacquard similarity. It can be used to identify a collection of almost similar document. न्यूज आइटम हो सकती है, वेब पेजेस हो सकते हैं, रिसर्च पेपर हो सकते हैं, ऑल दैट. किसी ने एक का रिसर्च दूसरे के कहा मेरी रिसर्च है, तो वो बिल्कुल वर्बोटम वही लिखा दिया और वही इंग्लिश यूज करी. मैं कल किसी का somebody's I was seeing the synopsis. I said this synopsis seemed to have been just taken from somebody. I don't think it is your writing. Then he says, sir, I have taken it from my friend, so I am going to redo it now. So that's again, you see similarity of the documents. You can see that from the way the person is writing, you can see what are the, that's what the plagiarism is also similar. Checking the plagiarized text may differ in small segment, or some portion of the document may have been changed, or even the ordering of some of the sentence may be changed. Mirror website, even the mirror website also make changes as per the local advertisement. The version of course material, even the version of the older course material and new course material, assignment, etc., available on different websites may be slightly different. Similar, just a moment. Similar news report, the news report about a news item may consist of similar text which may be appended with supplementary information for each newspaper. So that's again एक अगर तो प्रॉपर न्यूज कास्ट दे रहा है, कोई गवर्नमेंट न्यूज दे रही है और सबको पेपर को दे रही है, दैट्स ओके, तो इट विल बी सेम. बट इफ somebody is making a news and somebody copies the news, that's the plagiarism. That type of thing is objectionable and it can be sued. Then collaborative filtering and set similarity. In the past decades, e-commerce has gained acceptance by customer. अब सारे Amazon.com, Flipkart सारे होते हैं ना, सारे हो रहे हैं. Many of you who have purchased and have liked various items on these e-commerce websites get online recommendation for the purchase of certain item. आपको आता होगा, अगर आप एक आइटम खरीदते हो तो आपको 4 आइटम आता है कि ये भी ले लो, ये अच्छी आइटम है, दिस इज अच्छा. सो दैट थिंग इज it's a continuous process. It's a sort of collaboration between the user as the customer and the market. So online recommendation for the purchase of certain items, you may have observed that many items, those recommendations are very close to purchase that you would like to do in near future. So they guess from the your type of purchase you are making, they guess what are the other purchases you are likely to make. So similarly, of the set used address this problem. Two customers can be in a similar customer group if they purchase and like similar product. The similarity is determined by the Jacquard set similarity. However, please note that the number of customers as well as the product that can be purchased on any e-commerce website are very large. For example, two separate customers may be interested in purchasing books. They may purchase the same books available on data science and may rate them similarity. Please note they may also purchase many other books which may be bought by one of them. However, the problem of collaborative filtering and document similarity are different. The prime difference is in the value of Jacquard similarity. For document similarity, you are looking at JS Jacquard similarity AB in the range 50% or above. Whereas for the case of collaborative filtering, you may be interested if Jacquard similarity AB is as low as 10 to 25%. So this is the link analysis. So that's what again you can say bag customer 1, bag customer 2, ए बी 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 ए बी बी बी. तो इसमें पहला क्या है, एंड में आ जाता है ए का ए, बी का बी का बी का ए. बिकॉज इसमें पहला ए है, दूसरा ए के बी है, वो नहीं कंप्यूट होगा, बाकी तीनों बी सेम है, तो उसके ये आ जाएगा और ये सारा उनके सारी कॉम्बिनेशन आ जाएगी. सो 2/3 बन गया. सो दैट्स द set similarity in an important consideration for finding the similarity between these. So you can check up all the things and find similar things. So this is Jacquard similarity test that you can see by and or, by ratio of and or of A and B, set A and B. That is what you will get the similarity between them. Is it okay? So you have followed the Jacquard similarity of the document, of the for plagiarism, for everything you have known. It is A and B and A or B divided by A or B. That is the similarity. Okay. Is that all right?
Yes, sir, sure.
Okay. So finding similar documents, same thing you can do. So that's what step 1, create sets of items from the documents, perform enhancing and create document signature that can be tested by similarity checking, and perform locality sense hashing product, this and all that. So this is the shingles. So in order to define the term shingles, let us first try to answer the question how to represent a document as a set of items so that you can find lexicographically similar document. One way would be identify word in the document. कितने word है, कौन से word है. However, the identification of word itself is a time consuming process. कितने word है document पे, कितना document है, कितने हजार word है या 10,000 word है, कितने हैं. So one of the simplest and efficient way would be to divide the document into smaller subsystem. सारे document को break up कर लो छोटे छोटे system पर, and then say side 3 to 7. The advantage of this division is that for almost common sentences, many of these subsetting would match despite small changes. Even if somebody has taken the full sentence but small change भी करा है, वही पता लग जाएगा. So उसमें भी आपको similarity पता लग जाएगा कि ये similarity project है. So that is what bit by bit, hit and so on. You can just see this, that though this also one of the issues while making shingles is how to deal with white spaces. A possible solution which is used commonly would be to replace all the continuous white spaces character with a single blank space. So how do you use shingles to find similar document? You may convert the document in shingles and check small bits में लेके, जैसे ये देखिएगा bit A, T, B, by and all these things are there. So how do you use shingles? You may convert the document into shingles and check if the two documents share the same shingle. An interesting issue here would be to determine the size of shingle. If the size of shingle is small, then most of the document would have those shingles, even if they are not identical. For example, if you keep a shingle size of k is equal to 1, then almost all the character would be shingle, and these shingles would be common in most of the document, as most of them will have almost all the alphabets. On the other hand, bigger shingles may not be able to distinguish them. So you have to have ideal size is k is equal to 5 to 9 for small size. This is what is the conclusion, and that you can read it and all. Then next comes is min-hashing. This, if you can observe the set of shingles of a document in general, a large number of these you can see there are these. So therefore, you can find man-hashing of shingles to a smaller size. So as discussed in the previous section, the size is 5 to 9. That's what we said. It's a 5 to 9 characters and 9 bytes and all that. So thus, it will not be possible to accommodate the shingles in the memory of a computer so as to find the similarity of the document. Is it possible to reduce the stored size of shingle yet not compromise on much on the estimate of the similarity? So document set 1, 2, 3, 5, document set 2, 3, 4, document set 3, 1, 4, document set 4, 1 to this, then single document 1, set 2, set 3, set 4, इन सबको मिला के तो JS set A, set 1 to 4, so that will come the total number of rows having ones in column of both the sets and number of rows having one since a last one of the two columns. So that gives you the jagged similarity test and all that. So that's what is being done here. Is it clear? So jagged similarity test again is done by and on process, and you can see this is 2 by 3, 1 by 4, and all type of things which are coming. These are the various single documents. So first, second, third, fourth, fifth, and all that. So that's where the Minha's signature matrix is worked out from them, and then set 1, set 2, set 3, so that 1M, 1N, and all that, second, third, second, and so on, so that you can ultimately say, so this is the final formula, AJS set 1, set 2 is equal to this, AGS set 1 and 3 is this, A set 1 and 4 is this, and A set uh, 2 and 3 is this, and 3 and 4 are this, 3 and 4 is this. और सारा जो सारे सेट थे उनके दो दो सेट बना के उसका ये डिस्टेंस निकाल लिया है जैकेट सिमिलरिटी टेस्ट लगा के. So that's what this is completely done in that same manner. So that's all the set differences. उससे hashed signature ले लेते हैं, and after that the whole process is completed. Is it clear? Shall I repeat it again? So same add and or approach is there, but you compare various set 1, set 2, set 1, set 3, set 1, set 4, set 2, set 3, set 2, set 4, set 3, set 4, and so on, so that you can able to get the result. So that's what set 1, set 2, set 1, set 3, and so on. This is a locality sensitive string. उसको भी ये पढ़ लीजिए आप. You will find it is a very similar way. There is step 1, divide the overall set of signature matrix into horizontal portion of the set. Let's call them horizontal hands. This will reduce the effective size of data that is to be processed at a time. Use a separate hash function to hash the column of the horizontal hand into a hash bucket. It may be noted that if two sets are similar, then there is a very high probability that at least one of their horizontal hand will be hashed by some hash function to the same bucket. Perform the similarity checking in the pair of sets collected in each bucket. You may please note that the probability of hashing similarity sets to same bucket is low. So that type of, so this is the example given. So you can see that. So then next question comes the distance measure. How do you measure the distance between them? In the previous section, we used the Jacob similarity to find similarity measures. So a distance measure, say distance xy, is the distance between 2 points in the space. Distance is always positive. It can be 0 only if xy are the same point. The distance measured between 2 points is symmetrical. That is, distance xy is the same as distance yx, because distance to xy से और yx से same ही होगा ना. The distance 2 points would be the distance of the shortest path. The shortest path is a straight line. Curve तो बड़ा हो जाता है. Thus can be represented with the help of a third point, say t, by following this. Distance xy is less than distance xt plus distance ty. तो एक पॉइंट बीच में ले लिया, so that becomes a straight line xt and then ty. So that type of the. Let's discuss some of the basic distance measure in the following days. Euclidean distance, वो आपने पढ़ा हुआ है. Distance xy is equal to y1 minus x1 raised to power m upon 1 upon m, and I is equal to 1 to n. In the case m is equal to 1, you get the formula I is equal to 1 to n y1 minus yx1. So this is called Manhattan distance. मैनहट्टन डिस्टेंस, जो मैनहट्टन तो न्यूयॉर्क में है, लेकिन उसका नाम उन्होंने मैनहट्टन डिस्टेंस दे दिया. In case m2 m is equal to t, we get the final distance square, उसका अंडर रूट ले लिया. So you can verify the measure, satisfy all the properties of the distance measure, and this is a Jacob distance. As discussed, this A and B, A or B, the Jacob distance between these two sets is computed as this. This is Jacob distance 1 by Jacob similarity AB, 1 minus A and B, A or B. So that's the distance. Cosine distance is AB, A into B cosine theta. So 0 is equal to 2 into 1 into theta, and cos theta is equal to 0, so theta is 90 degrees. So you may check of this measure also fulfills the criteria of measure. It may be noted that the range of cosine distance is evaluated between 0 and 180 degrees only. You may go through further reading for more detail. Edit distance. Edit distance may be used to determine the distance between two strings. It can be defined as follows. Consider two strings. String A consisting of n character, A1 to AN, and A string B consisting of B1 to Bn. Then edit distance between the two strings is the minimum number operations that are required to make string identical. These operations are either the addition of a single character or the deletion of a single character. For example, the edit distance between the string A, that is A, B, C, D, E, F, and B is A, C, D, F, G, would be 3. Because if you see A and B and divided by A or B would be 3, as you can obtain B from A by deleting B, deleting E, and inserting G at the end of the string. However, finding these operations may not be easy in code. Therefore, edit distance can be computed using the following method. Step 1, consider two strings, string A consisting of a character A to AN and string B, B to BN. For is find a subsequence which is the longest and has the same character sequence in the two strings. Use the deletion character operation to do so. Assume the size of the subsequence. Compare the edit distance using the formula edit distance AB is equal to n plus m minus 2 into ls, where A is A, B, C, D, E, F, and B is A, C, D, F, G. The longest common subsequence is A, C, D, F, which is 4 characters long. Therefore, the edit distance between the two strings becomes 6 plus 5 minus 2 into 4. Ls becomes 4. So 6 plus 5. N is 6 and B is 5. M is 5. So this becomes 3. You can verify distance and distance in a proper distance. So this is a simple method of finding the distance. Is it clear? Understood it? These are some of the questions which will be asked because that is important for big data analytics. Hamming distance. Hamming distance is one of the most and used distance in digital design and error detection in digital system. For example, by mapping of mean term into uh, Kurbansky's map or single error correcting code, the Hamming distance is defined as the distance between the components of two vectors, especially when these vectors are of type Boolean, the 0, 1, 0, 1, 0, 1, let's say. So that is what it says. The Hamming distance between the vector A and B is 4. So that's what he is working because there are only uh, one similar, uh, and second similar, zero similar, zero similar. So these are 4. So that's where A and B is 4 because 1 1 0 1 similar नहीं 1 0 similar नहीं 1 1 फिर similar आ गया 0 0 फिर similar आ गया 0 0 फिर similar आ गया 1 0 फिर similar नहीं 1 0 फिर similar नहीं तो 4 similar आ गए तो उसमें distance हो गया A and B का ओके तो A and B एंड वो सारा जो प्रोसेस है वो पॉसिबली उसी को बोलियन वेक्टर को लेके करना भी चाहिए. So we have done Hamming distance, we have done edit distance, we have done cosine distance, we have done Jacob distance, and then similarity, equivalent distance, and then we did similarity test and all that, so that locality sensitive Hamming. So all these are very, it becomes tedious when you're talking of long documents and all that, but that's the method. Simplified methods are suggested so that that can be used for finding data. So now introduction to other techniques. This is textual analysis. So how do you analyze the text? That is, data, textual data is produced by a large number of sources of big data. For example, email, blog, website, etc. Some of the important types of analytics that you may perform on the textual data are structured information, extraction from the extraction from the unstructured textual data. The purpose here is to generate information from the data that can be stored for a longer duration. So, for example, government may find the list of medicine that are being prescribed by doctors in various cities by analyzing the prescription given by the doctor to different patients. Such analysis would essentially require recognition of the entities. So, meaningful summarization of single or multiple documents, question answering, all these are important. Sentence analysis is also important. So, audio video analysis is also important. The purpose of the audio and video analysis is to extract useful information from speech data and video data. So वीडियो एनालिसिस सीसीटीवी से जो आप सारे जगह सीसीटीवी लगा रहे हैं उससे हमें जो डेटा मिलता है that again it can be used to perform indexing of videos so as to find relevant information of a in later time. So social media data analysis, because the one large chunk of present day data, such data can be part of the social network, microblogging, wiki-based content, and many other related webs. So these are the again analysis done. Then predictive analysis. The purpose of such analysis is to predict some of the patterns of the future based on the present things. Supervised and unsupervised learning that we have done earlier also. So supervised learning is used already available knowledge to generate models, and unsupervised learning is generates its own set of classes and models. One of the most common example of unsupervised learning is creating a new categorization of customer based on their feedback on different types of products, etc. So these are the other type of thing. So that finishes our. You can see the question answers, and that covers up our section 9. Then we go to, oh no, 10 पर जाते हैं. 9 के बाद 10 आता है. ये कहाँ गया 10? अरे 10 कहाँ गायब हो गया?
सर गलती से आप पीडीएफ कट कर दिए हैं.
Yeah, let me go back to. Unit 11. Ah, so sorry, I missed unit 10. So that's unit 10. You are able to see that?
यस सर.
Yes, sir.
So I, as it is, I think we should be able to do 3 units. Fourth unit we'll do tomorrow. So mining data stream, that is a model for data stream processing, data stream management, queries of data stream and queries, and so on and so forth. These are the things which are studied here. And Bloom filter algorithm to count different elements in a stream. So that's the type of thing which we do. Now, in the previous unit, we have gone through the concept relating to the big data and different similarity functions, and how to study the data streams and all that. So this unit explains the characteristics and model of data stream processing. How do you process the data stream? Because that was trying to have the data in a proper form, and this is now processing the data. Okay, so define the characteristics of data stream, discuss model of data stream presentation, processing, explain the uses of data stream, illustrate the example of data stream queries, explain the rule of Bloom filter, and explain the role of blue filter, and explain an algorithm related to data stream this. So that data stream पर पहले आ जाते हैं. It usually the data resides in a database naturally. So all the queries have to be answered. So you have to have all the uh, information, so that the mining data stream is a process of extract knowledge in real time from a large amount of volatile data, which comes in an infinite time. So that's the model for data stream process. So ये देखिए, assume D is the data stream, T1, T2, where T1, TIC is the first transaction, second transaction, and so on and so forth. There are three different models for data stream processing, namely landmark, sliding window, and damped. So figure 1 and discussed will follow. So A, B, C, D, F, G, etc. Then A, B, C, D, and B, C, D, and all that. So landmark is there. So sliding is there, so that you can slide, so that BCD all that. So sliding करके हो सकता है, this is landmark हो सकता है, this is decreasing dampened window and all that. So that type of thing, so that you are sliding, and from sliding you are able to get some this here it's a landmark total thing is there. So landmark model, the model finds the frequently used atom in entire data stream from a specific time, so known as the landmark. So that's what the landmark was. The first one, A was landmark. Okay, सारे stream आ गई. Then second one is the sliding window. See, this model stores recent data in sliding window from a certain range and discards old data. So this takes this data, ये जो green है, rest it discards. Damped model, the model is also called a time fading model, as it assigns more weights to the recent transaction. So to the recent transaction, because this is the recent transaction, it gives more model and it decreases the weight to the old models. Okay, so you may use any model for data stream processing, but how are data stream managed? Next section discusses the data stream management system. So now we'll study the data stream management, because this was the models, three models, and now we are discussing the data. So DBMS and data stream management, data DSMS, is who control how data enters into the system. So you know DBMS क्या होता है? The staff assist with management of database, SQL inserts, command and all that. You know SQL and all that. Now DSMM में क्या होता है? The management cannot control the rate of the input So, for example, the search queries that arrive at Google search engine are generated by random people around the globe who search for information as at their respective pace. Google staff literally has no control over the rate of arrival of the queries because किसने कब इंक्वायरी करनी है वो तो इंडिविजुअल पर डिपेंड करता है. Google doesn't have to control, but if they have kept it open, anybody can inquire anything and all that. Have to design and architect their system in such a way that it can uh, it can easily deal with the varying data set. Data stream management system extracts knowledge from multiple data streams by eliminating undesirable elements. As shown in figure 2, this is what is shown. See, that's the, for example, data stream management system knowledge. इसमें से ये है सैंपल ये डेटा इग्नोर करके the source of data stream includes internet traffic, online transmission, satellite data, sensor data, lab event data, real-time surveillance system, and all that. So this is the figure 3 shows standing queries, stream process, go to the archival storage, working storage, output stream, and so on. So that's the type of thing which has happened in shows the detailed view of data stream management system. The component of the system are described as follows. So this is preprocessor, stream and entering and output. This is a preprocessor and stream, this input, output, and all that. Stream entering, there can be several stream entering in the system. Conventionally, we will assume that the element at the right end of the stream have arrived more recently. The time goes backward to the left, that is further left, the earliest the element entered system. Archive storage, working storage, and all that. So this is the stream processor, output stream, ad hoc queries, जो भी ad hoc queries आती है उसको यहाँ होता है. And this is input stream data system for arrival time and all that. Archival storage, there is a massive archival storage because देखिए, for example, Google is answering all type of question. गूगल दिल्ली के भी क्वेश्चन देता है, जयपुर के क्वेश्चन देता है, तमिलनाडु के क्वेश्चन देता है, मद्रास के क्वेश्चन देता है, केरला के क्वेश्चन देता है, सबके, और वहाँ यूएसए के क्वेश्चन देता है, यूरोप के क्वेश्चन देता है. सो पीपल आर एवरीवेयर ऑन द वर्ल्ड, सो दे गो फॉर गूगल. सो दैट मीन्स दे हैव ए big archival storage all over the world so that they are able to have the count, the query answered at all the places. Say, for example, if you ask for what is happening to the today's cricket, Sydney में हमारा इंडिया ऑस्ट्रेलिया क्रिकेट हो रहा है, वो क्या हो रहा है, immediately it will come out with this cricket stream and tell you what is happening there. So that type of thing is about limited working storage. It might be a main memory or a flash storage or even magnetic disk, but we assume that it holds important parts of the input stream in a way that supports fast execution of queries. So fast execution query, अगर आपको पास 1 मिनट में आपको query का आंसर नहीं मिले, you will feel upset. कह रहे क्या है, बहुत देर लग रहा है. So queries of the data stream, ad hoc queries, standing queries. Example of data streams is mining query system streams. The first example is to query stream and search engine like Google. For instance, Google Trends wants to find out which search queries are more important, much more frequent use and all that. So from there it says all these things. And then mining click streams are another source of very rapid input. A site like Yahoo has many millions of users each day, and the average user probably clicks a dozen times or more. The question worth answering is whether URL are getting clicked are on a lot more in the past 1 hour than normal, so on and so forth. JP packet, IP packet, Internet Protocol packets can be monitored at a switch, the element of the stream and all that. This you just read it. These are input tuplets and arrival rate, critical this. You can just read it all that. So next question unit comes in data sampling and data streams. So you have to take care of samples that you need to consider for simple samples should be unbiased. Second, the sampling process must preserve the answer to the query or queries that may like to ask about the data. So, thus, you require a method that preserves the answer to the query. The following example: this Google has a stream of search queries that are generated at all times. So, you can read this. One of the sampling technique is given that can be used for data stream and all that. However, the query to find the fraction of unique queries cannot be answered correctly from a random sample of the stream. So that's again very important. So one of the sampling technique that can be used for data stream to answer the queries may be randomly select 1/10 of the stream. For example, if you want to know what using the 1/10th sample of the data stream, the computed fraction would be very close to the actual fraction of single word queries over the entire data stream. Thus, over the month, you would be testing 1 upon 10th of the data stream as sample. If these queries are selected at random, the deviation from the true answer will be very small. So this is the representative sample. So you can read this. In this section, we discuss the need of representative cycle with the help of an example. For example, we know that the length of cell sample is 10% of the length of the whole stream, as mentioned above in section 10.4. So that's where suppose a query is unique in the data stream, it has only 1/10th of the chances of being selected, so on and so forth. However, suppose a search query appears exactly twice in the whole stream, the chances that first occurrence will be selected for the sample is 10%, and for the chance that second will be selected by 90%. That's again. So, moreover, the first occurrence could not be selected, but the second is selected also has 9% chances. So that's again question. Similar, the query that appear on the stream 3 times has 24.3% chance of being selected as unique queries in the sample. So these are the various numbers which you have to remember. So they can be worked out and all that. So when you count the number of unique queries in the sample, it will be an overestimate of the true functions of the unique queries. So you can go through this and come back. Okay. So sampling key value pairs. The idea which has been explained with the help of an example given above is really instance of general idea. A data stream can be any form of key value pairs. You can choose sample by picking a random key set of desired size and take all key values pairs whose key falls into the accepted set regardless of the associated values. So example salary range. So assume that data stream elements are tuple with three component ID for some employee, department, and apply work for and the salary of that employee. So stream data, tuplets, employee ID, department, and salary. For each department, there is a salary range which is different between the maximum and minimum salary. So query is what is the average salary range within a given department? So there is a key department, value employee ID, and salary, and so on. So that's again the so you can say when you compute the average of the ranges, you might be off a little ये क्या हो गया? ओके, अच्छा, अब आ गया filtering data stream. So that's another question. Bloom filters and all that हम पहले discuss किया था. In the previous section, you were answering query using the recent window item. You may have to use filtering of data stream for this. So this is what a Bloom filter is there. Bloom filter enables us to select only those items in the stream that are on a some list or set of items in general. So need of Bloom filter क्या है? Let's explain the need of Bloom filter. So web crawler performs many crawling tasks and uses different processes to crawl pages. The crawler maintains a list of all URL in the database that has already found in to its goal is to explore the web page to each URL to find the additional URL that are linked to these web pages. It assigns that URL to any of the number parallel tasks. These tasks stream back the URL they find in the link they discover in a page. However, it's not expected to have the same URL to get into the list twice, because in that case you will be wasting your time in crawling and page twice and all. So each time a URL comes back to the central controller and central controller, it needs to determine whether it has seen that URL, therefore, and discard the second report so that you can create an index, say hash table, to make it efficient to look up the URL and see whether it is already among those web pages that has been already indexed. But the number of URL are extremely large, so you have to take care of it. That disk access every time URL is to be checked. This should be time-consuming process. So therefore, you need a Bloom filter. When a URL arrives on a stream, pass it through a Bloom filter. This filter will determine if the URL has already been visited or not. If the filter says it has not been visited earlier, the URL will be added to the list of URL that need to be crawled, and eventually it will be assigned to some crawling task. But the Bloom filter can have false positive also, which would result in assigning name of the URL as already visited, while in fact that it was not. The good news, if a Boolean filter says that URL has never been seen, then that is true. अगर कहेगा never seen, then it is true. But अगर कहेगा एक दफा visit हो चुका है, that's possible. That error is possible. Already visited, that, while in fact it was not. So that type of error is possible. So working of Bloom filter. Bloom filter itself is a large array of bits, perhaps several times as many bits as there are possible elements in the stream. The array is manipulated through collection of hash functions. The number of hash functions can be one, although several hash functions are better. In some situations, even a few dozen hash functions may be a good choice. Each hash function maps a stream and so on. You can see that during initialization, all the bits of the array are initialized to 0. Now, when a stream element, say x, arrives, we compute the value of ln x, hx for each hash function h that are to be used for Bloom filtering. A hash function maps a stream of element to an index value on a Bloom filter array. In case the index value is 0, then it is changed to 1. The following examples explain the working of Bloom filter. Example of Bloom filter, अब देख लीजिए क्या है. For example, the size of any array that going to be used for Bloom filter is of 11 bits. That is, n is 11. Also assume that the stream that is to be filtered consists of only unsigned integer of 12 bits. That is, stream elements is equal to unsigned integer. Further, for the purpose of this example, let us use only two hash functions, h1 and h2. The first hash function h1 maps on integer x to hash value h1x. as follows. Write the binary value of the integer x, select the bit at the odd bit position starting from the leftmost this. Extract those uh, odd bits of x to another binary, say XML. X, x odd. Take module as x odd module 11 to map x into hash value h1x. So h1x is computed in exactly the same manner, except that it collects the even bits position of the binary disk. So the module is also computed x uh, x even module 11. So next you will initialize the value Bloom filter array index 0, 1, 2, 3, 4, 5, 6, 8, 9, 10, and then Bloom filter is 0, 0, 0. So that which is represented by this. Then hit bit position 12, 11, 10, and 1. So you can see binary equivalent this 2048, 10 this, 520, and so on. Ultimately, it goes to 1. So this is 5 decimal this. So Bloom filter contents after inserting hash value of 25. So this is what the ultimately function comes up there. Okay, and blue filter content after steam element is 159, bloom filter content is 00100, etc., etc. So that's again blue filter content after inserting hash value of 159, and so on. You can say blue filter after inserting value 585, and so on. These are the various y equal to 1. So all these things are available so that you can work it out and see that your blue filter comes with the proper. So you are able to use that elements very, very clearly. Is Bloom filter understandable? Have you understood? Shall I repeat it? Hello? Are you there, all the people?
Yes, sir, we are here.
So it's okay? You will be able to read it? Yes or no?
Yeah, we able to read it, uh, but if you explain again, it will be like give more understanding.
Okay. Shall I explain it again?
Yes, sir.
Okay. So first has function h maps an integer x to a hash value h1 as follows. So देख लीजिए वाली value से okay. So Bloom filter array index 0, 1 to 10 and Bloom filter is 0, 0, 0. So then bit position 12 is 2048. This is 2 raised to power 12. No, 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 no. This is 2 raised to power 0, 2 raised to 1, 2 raised to 2, 2 raised to 3, 4, 5, 6, 7, 8, 9, 10, 11. So 2 raised to 11, 2048, 10, 24, 5, 12, and so on. So x is equal to 25. So that's the value वो यहाँ आ जाता है बिकॉज यहाँ तो सारे मोर देन 25 है यहाँ 1 1 फिर ये 0 0 1 सो देन एक्स ऑड ये ऑड है ये 11th है ये 9 है ये 7 है ये 5 है ये 3 है ये 1 है सो देन h1x ये 000101 is equal to 5 in decimal. Hx is 5. So I 5 mod 1 is 5. So therefore x is 0 1 1 0 0 1 because ये जो है यहाँ 5 बनता है. So then again x even becomes 0 0 0 0 1 0. So hx becomes 40 1 2 3 4 40 10 जैसे 1 2 3 4 40 10. So it becomes 2 in decimal. Hx is equal to 2 mod 1 is equal to 2. So that's the done there. So similarly Bloom filter array, so 0 1 to 10, so फिर उसको ले लो 12 248 and so on. अब इसमें x इक्वल टू 159 लगा लिया तो 159 यहाँ बनता है 128 प्लस 16 प्लस 8 प्लस 1 प्लस 1 प्लस 1 159 बन जाता है. यू अंडरस्टैंड ना? जैसे यहाँ x यहाँ 5 बना था, कैसे बना था? 0 0 0, यहाँ 4 है, नहीं यहाँ 5 है, 5 है, बाकी 0 0 1. तो ये तो दिस वाज 5. तो इसमें हमने कैलकुलेट किया 0 0 0 1 0, तो ये 1 का 2 बन गया. तो this is the second, this is 0, this is 1, so इसका 2 बन गया. this is 2 raised to power 0, 2 raised to 1, so 2 बन गया. so decimal this is equal to 2, so mod 11. so इसका ये हो गया कि 159 लिया है, तो 159 128 प्लस 16 प्लस 8 एंड प्लस 4 प्लस 2 प्लस 1 159 हो गया. उसी हिसाब से कैलकुलेट करा तो ये 7 इन डेसिमल, दिस इज 7 बन गया. तो 7 कहाँ से बना? ये इट इज 8 प्लस 4 प्लस 1. सो यहाँ से क्या हो गया? ये 1 हो गया, ये 2 हो गया, 2 3, ये हो गया 8, 3 और 8 11, 11 हो गया इन डेसिमल. hs equal to 11 mod 11 is equal to 9. So 11 mod 1 is equal to 9, because is equal to 0, sorry. 11 mod 1 is equal to 0. 7 mod 1 is 7. 11 mod 1 is 0. So that again यहाँ पर x लिया 585. 585 कहाँ से लिया? ये 512 यहाँ से लिया, 64 यहाँ से लिया, 4 यहाँ से लिया और 1 यहाँ से लिया. दिस बिकम 585. उसी हिसाब से वो 9 इन डेसिमल दिस दिया, एंड 18 mod 1 is 7. 18 mod 1 is 7 बिकॉज ये क्या है? 18 है. उसको मॉड जब हम कैलकुलेट करते हैं तो उसको 7 आ जाता है. सो दैट टाइप ऑफ थिंग ब्लूम फिल्टर से चलता है. सो दिस इज व्हाट यू कैन सी, ऑल द ब्लूम फिल्टर्स वर्क्स लाइक दिस. इज इट क्लियर नाउ? या यहाँ देखो 5 आ जाता है, ये 2 raised to power 0 है, 2 raised to 1, 2 raised to 2, 4 plus 1 5. So this is h to y is equal to 5 mod 1 is equal to 5. Is it okay? नहीं समझ में आया अभी? Shall I repeat? Okay, यहाँ तो समझ में आया था, अप टू 159 समझ गया है.
Yes, sir. Yes.
तो और 585 कहाँ से आया? देखो 512 ये आ गया, और 64 ये आ गया, 576 आ गया, और ये 4 आ गया, 76 1 77 और 1 78. 85 कैसे हुआ? अरे 8 है ना, ये 8 आ गया. 512 प्लस 64 576 प्लस 8 583 प्लस 2, सब 585 आ गया. राइट, 585 आ गया ना. एंड इसका ये रिजल्ट बन गया 001001। ये देखो 001001, ये के 1 हो गया और ये 8 हो गया, 8 + 1 9, 9 in decimal. So H1X is 9 mod 1, which is 9. So that's how it is calculated, right? Is it clear? That was 10th.
10 सर चल रहे हैं।
हाँ, तो
ठीक है
अभी
सर,
आवाज आ रही है मेरी? ऑडियो कर दिया है? ओके, फाइन, ऑल द बेस्ट। सॉरी, गड़बड़ हो गया था बेटे। हेलो, इट
Yes,
क्रिएटेड
sir.
प्रॉब्लम, नाउ इट इज ओके, सेट ओके। सो यू हैव सीन 159 कैसे बना, राइट? और 585 कैसे बना, देखो 512 + 64 + 8 + 1, सो 585 बन गया। सो उसी हिसाब से ये इसका जो नीचे एक्स और वो आ गया, फिर उसका ये 9 बन गया, एंड देन इट इज 18। 18 का मॉड 11 1 का जो है तो 7 आ जाता है। सो 18 मॉड 11 है, इसका 7 आ जाता है, बिकॉज 18 mod 11 will be 7. So 11 mod 1 will be 1 mod 1 will be 0. 11 mod 1 will be 0. 11 mod 11 will be 0. This is 11 mod 11. This is 18 mod 11. So इसमें 18 - 11 7 हो जाता है, ये 11 - 11 0 हो जाता है, और ये 2 - 1 2, ये कैसे, 2 mod 1, बिकॉज वो कुछ में डिफरेंस नहीं आता, 2 हो जाता है। तो दैट्स इट। So that way you can see 18 mod 11 7 and so on, so that you can see all these figures there and all that. So it's okay now, blue filter. You can try it again and then come up with suggestions tomorrow. Okay, so you can go through this algorithm to count different elements in stream. So that's what is the given a good uniform distribution of number as shown in table 1. So you will see that 0 binary representation, this is 7 is 1 2 3 और 4 7. So and position of the rightmost bit, इसकी 0 कैसे हो गया, इसकी 0 है, rightmost bit, ये rightmost position of the rightmost set bit, presuming that the index value of least significant bit is 0, it implies that probability of the rightmost set bit drops by a factor of 1/2 with every position from the lower standard bit to maximum standard bit as shown in figure 4. अच्छा, वो ऐसे करते हैं, तो lower standard bit and maximum standard bit. अरे क्या, the probability reduces by factor of 1/t for each bit. So it's a Flageolet-Martin's algorithm है ये. So probability this and all. So this is Bloom filter this and all this is somebody this. So this finishes your chapter 10. We'll can we continue with the 11th and then shall we do tomorrow? That is what we did. We did page ranks and all that. Let's the define link analysis. We'll define link analysis क्या होता है. Link analysis is a data analysis technique used to in network theory to analyze the links of the web graph. That's the one. The purpose of link analysis क्या होता है? Purpose of link analysis to create connection in a set of data that can actually be represented as network or the network of information. For example, in internet, computers or routers communicate with each other, which can be represented as a dynamic network. So represent the World Wide Web we know as a graph, but www can be represented a directed graph. That is what we'll see that. And page ranking, page rank is an algorithm that was designed for initial implementation of the Google search engine. The page rank is defined as an approach for computing the importance of the web page in a big web graph. So page rank, that is basic concept क्या है? A page or a node is a graph in an important as the number of links it has. Not all in links are equal kind of link. The link coming from important pages are worth more. Thus, the importance of given pointed page depends upon the importance of the others. Each one has its own importance and all that. Page rank score graph. So figure 1 shows that the node B has a, this is the figure, node B has 40%, C is 36%, A is 30%, T 3%, 5%, 10%, and this 10% is divided 2%, 2%, 2%. So this is the main thing is 36, 40, and 3 plus 5. This is 50 plus 36, 86, and 86 plus 6, 92, 97, and 300%. So that's what is the node B has a very high page rank. Scoring is almost pointing to it. And node C also has a relatively high page rank, which is also very important. Node B is pointing to it. The very small purple colored link node have relatively small page rank. The page rank score of node D is higher than page rank of node A because D points to A. The node E has kind intermediate page ranking score and E points to B and so on. So the E points to B and B and C are interrelated. They are each pointing towards each one. So D is pointing to B, whereas D is pointing to A. E is pointing to D. So that's what they say. Since node E has a kind intermediate page rank score and E points to B and so on. So on page rank, score of node D is higher than the page rank of A because D points to A. Because D points to A. D points to A, therefore score of A is higher. So D is higher, score of node D is higher than the page rank of node A because D points to A. So it's a higher, D points to A, so it is higher. So similarly, E points to D is higher anyway. These points to purple points to A, B. इसका क्या है? The very small purple colored nodes have relatively small page rank score as it pointed by a web page that has a low page ranking. So that type of thing which it says about that. The node B has a very high page rank score because it has a lot of other pages pointing to it. B has a very high, all these are pointing towards this. All these small, this as pointing, and as well as C is related to this. And node C also has relatively high page rank score, even though it receives only a single incoming link. The reason behind this is that very important node B is pointing to it. So the bada important node जो B है is pointing to this, and C is pointing to this. So that's right. So C is important, but B is a bigger node because all these nodes are pointing towards B, and D is pointing towards A. That means D is a bigger node. E is pointing towards D, therefore E is a bigger node. So different mechanism for finding page rank. So different mechanism. Each link is considered as a vote, and the importance of given vote is proportional to the importance of the source web page that is casting the vote or that is creating a link to the restriction. Suppose that there is a page J with an importance R1. The page J has n outgoing link. The importance of RJ of page J basically gets separated all outgoing. अगर वो उससे 6 लिंक दे रहा है तो 6 तरफ स्प्लिट हो जाएगा उसका. So that's where each link gets R1 divided by the n votes. That is R1 vote n votes. So that's why it's not, because if it is going by single strip, that is fine. जैसे B से A की तरफ जा रहा है अकेला ही, तो लेकिन अगर B से बहुत तरफ से जा रहा होगा, then it will be divided by that number. Okay. So that's, for example, here you can say it's ये इधर आ रहा है, इधर जा रहा है, इधर जा रहा है, इधर जा रहा है, तो इट इज R/3, 1 2 3 से इधर एक इधर जा रहा है, एक इधर जा रहा है, तो R1/2. ये क्या है, एक इधर जा रहा है, एक इधर जा रहा है, एक इधर जा रहा है, तो दिस इज R1/3, RJ/3. ये J के सारे 3 से हो रहा है. ओके, यू अंडरस्टैंड. ये एक इधर जा रहा है, एक उधर जा रहा है, एक आ रहा है, तो लेकिन RI/2, ये RK/3, बिकॉज 1 2 3, तो 3 बाहर जा रहे हैं, तो RK/3 हो जाए, 3 से मोटे हो जाती है. So the flow model, this model is basically the vote flow through the network, so that this is why this is called the flow formulation or a flow model of page rank. To understand the concept, let's use a web graph of www that contain only 3 web pages named ABC. Please refer to the figure 3. So this is the figure 3. ये देखिए, इसमें इसका बी से सी की और सी से बी की है. इसी तरह ए से बी, बी से ए, तो एंड देन ए से भी कंबाइन इसका अपना भी हो रहा है. सो दिस इज B/2, A/2. बी का एक इधर जा रहा है, एक इधर जा रहा है. अच्छा, सी का एक इधर आ रहा है, जिसे सी का बताया नहीं है, लेकिन ए का एक इधर जा रहा है, एक ऐसे जा रहा है, A/2. So that's where it is R2 is R2, RA/2, RA/2 plus RB/2, RA/2, RB/2, RA/2, RB/2, and RB is RA2 by RC, एक सिंगल RC, RA2/2, बिकॉज ये दो है, एक इधर जा रहा है, एक इधर जा रहा है, एक ए को जा रहा है, एक सी को जा रहा है. सो B/2 प्लस सी का RC is equal to RB/2 because it is ये दोनों तरफ जा रहा है. So that's the type of thing. So RA plus RB plus RC is equal to 1. RA is 2/5, RB is 2/5, RB is 1/5. 2 4 plus 1 5, 5/5, 1. RA plus RB is equal to 1. So that makes it clear. Web structure and associated issues, इसमें देख लीजिए, you can read that. It's a simple process is there. Use of page rank in search engines, that also you can go through because it's a simple process. Same way, ये देखिए graph है, directed graph with 5 nodes, so that each node is well covered. Say A से B and C से B, ये 2 से नहीं, ये पूरा कवर नहीं है, ये 2 कवर कर रहे हैं. एक ये, एक ये, एक ये 3 से कवर हो रहा है. 1 1 2 3, ये 3 से कवर हो रहा है। और ये क्या है, 1 2 3, ये भी 3 से कवर हो रहा है। 1 2, ये 2 से कवर हो रहा है। So A is being covered from 2, C is being covered from 1, and B is being covered from 2, and C is being covered from 2, whereas D is being covered by 3. 1, 2, 3. And D is giving node to 2. So that type of thing is there. So that the graph in figure 4 can be written with the following matrix, where ith row is representing the ith node. So that's the matrix ये हो गया 1/3। वो आप देख लीजिए 1/3 1/2 कैसे बनता है, उससे 0 0 1/2 1/2 1/3 1/2 1/3 1/2 1/3 1/2 1/2, and this is 1. Because this was this was 1. D has 2 outlink. R2 by 3, R with 3, as node D has in-link from node A, node B, and node C. These nodes have 3, 2, and 1 outlink respectively. That's it. And this is R3 by R2, R3 by 2, R3 by R2, and this is R2 by R2, and that's a 1. As node A has a in-link from node D and node E, both which has 2 outlink. Node A, ये node A कहाँ है, ये है. This has 2 link. एक तो ये outlink है. These are the एक outlink ये, एक outlink ये, एक outlink ये, 3 outlink है. And in-link there are 1 and 2 in-link. So therefore, so node A has in-link from node D and node E, both of which are 2 outlink. ये कैसे हो गया? A has 1 2 in-link and 1 2 3 outlink. गलत कर दिया उसने. Node A has in-link from node D and node E in-link from node D and node E. Node D and node E. Okay. The one in-link हो गया, then outlink ये जो. गड़गड़ है लगता. As node A has in-links from node D and node E. Node A has in-links from node E, C, E, and D. Node A has in-links. They have both 2 outlink. एक ये, 2 outlink. ये एक outlook, एक dot. This is also 2 outlink. ठीक है. So this is 2 outlink, 1, 2. This is 2 outlink, 1 and 2. So that's why it is RD by 2, RC by RE by 2. That is RA. So that's so similarly RB, RA by 3, RB is this R 1, 2, 3 कैसे हुआ? नहीं 2 ठीक है. RA by 3, RA by 3. RA से 1 2 3 है. RA से एक आउटलेट, 2 आउटलेट, 3 इनपुट. 3 outlink. So RA by 3 and RE by 2, RE by 2, एक दो, RE by 2, ठीक है. So then RC is, it has 1, 2, it has RB by 2, RB by 2 एक और दो, and R A by एक दो तीन, RA by 3, ठीक है. RA by 3, RB by 2, and RD में क्या हो गया? RD में एक C से हुआ, A से हुआ, एंड A से हुआ, B से हुआ, C से, E से कितना हुआ? As node D has any link from node A, node B, and node C nodes. So these nodes have 3, 2, and 1 outlink. That is, node A has 3 outlink, 1, 2, 3. And node B and C node, these nodes have 3, 2, and 1. So B has 2, 1, and 2. Outlinks are 2, 1, and 2, and 3 by 2, and uh, C node has 1, only 1. So that is RC by 1. So that's okay. So RA by 3, RB by 2, RC. So that's it. So similarly, RE has 2 outlink, 1 and 2. So that's why it is RD by 3. RE is एक एक और दो, एक ए है, एक ये है, दो आउटलिंक है डी से. So that's where it is RD by 2. So that makes it clear. So this is the graph which becomes pentex हो जाता है और उससे सारा ultimately you calculate it. So you get R square 5 by 12, 1 by 3, 1 by 4, and so on, R6, and so that where your R5 is this, R4, repeated application, you will get various cases and all that. So here is the first question. Does the equation 1 converge? We multiply the matrix M with R to compute R iteratively from initial state. So there are two nodes and so on. If you calculate this, ultimately it becomes 1 by 0, it becomes infinity. So in that next time step, the value will flip. And now when we multiply again, the value will flip again. So spider trap ho gaya. So spider trap problem 2. So here is the second question. Does the equation 1 converge to what we want? So let's consider this. So there are two nodes, node A and node B, and one edge. Here A starts with score 1 and B starts with score 0. The matrix MS, so M is equal to 0, 1, 0, 0. So R1 is equal to this, R square is equal to this. So that dead end problem. So as we converge to the vector of 0, which is a problem. So spider trap and end problem in page rank. In the dead end problem, the dead end are those web pages that have no outgoing links as shown in figure 7. Such pages cause importance to leak out. The idea behind it that whenever a web page receives its page rank score, then there is no way for a web page to pass this page rank score to anyone else because it has no outlink. Thus, page rank score will leak out from the system. In the end, page rank score Of all the web pages will be 0. So this is called the dead end. So this is dead end page. So spider trap and dead end page. So solution to spider trap problem. So random teleports. The random walk is known as the random process which describes a path that includes accession of random step. Figure 8 shows a graph with node C being spider trap. कौन सी फिगर को बता रहे हैं? Figure 7. This is the spider trap. Figure 8A. Yeah. So random teleports approach. So this changes to this. So this one, a random walk, it shows a graph which node C is being spider trap. Node C is the spider trap. C is the spider trap because it goes back to this. So whenever a random walker basically stuck in an infinite loop because there is no other way. The way Google has solved the problem to the spider trap is to say that each step the random walker has two choices. With some probability B occurs, the random walker will follow the outgoing link. So the way we can think of this now is that we have a random walker that whenever a random walker arrives at a new page, flips a coin, or if the coin say yes, the random walker will pick another link of the random and walk that link end. If the coin says no, then the walker will randomly teleport, basically jump to some other random page on the web. So this means that random walker will be able to jump out or teleport out from a spider track within only a few time steps. After a few time steps, the coins will say yes, let's teleport, and the random walker will be able to jump out of the trap. Figure 8 shows a graph with node M being spider trap, where random walker will teleport out of the spider trap. So that's where ये देखो outpost हो गए etc. So these are the spider part. Solution to the dead end problem, always teleport. So this is the teleporting there. Always teleport approach to. So half, half, half. And this is made it different. So that's what comes up training. See, it's a combination of matrix manipulations. You can see that. आप लोगों ने मैट्रिक्स पढ़ा हुआ है ना?
हाँ जस्ट सब मैथ्स पढ़ेंगे.
Yeah. So ये देख लेना. And page rank computation using map reduce. वो हमने map reduce करा था कि कैसे करना है map reduce. So we said Python programming will be used for map reduce approach and all that. So input mapping, shuffling, reducing. The node will now process the respective group of output data by aggregating the shuffle phase value. The ultimate output will be from shape of list K3 B3. So this is a list of K3 B3 से यहाँ से shuffling, reducing. So this is a big data, structured data, big data, structured data, semi-structured data, big data 1, structured data 1, semi-structured data, big data, data 1, semi-structured, that is a big one, then data 1, send 1, semi 1, and structure 2, big 1, data 3, semi this, this. So this is listed K1, K3, V3, K2 list V2, K2 V2, K1 V1. So example of map reduce, how this is done, say reducing map from here, from big data, it goes to splitting mapping, shuffling, and here in the green area we are reducing so that big data को data 1, data 2, data 3 में reduce कर दिया and that's what it is. कहीं semi structured है, कहीं structured है, big data है, data 3 है. So that's what. So this is a program which does that. So this is the topic sensitive pager lag. So that also you can go through this. So this is the matrix link spam. So when we want to calculate spam from the mail, so that can be done with this process and all that. अब बहुत से लोगों ने spam by AI करना शुरू करा है. So hubs and authorities, you can see that the hub and authority side. These are the hubs. These are the hubs, and these are the authority side. So that hub and authority, this you can see that. So that covers up most of the unit. You can go through that. If you have some problem, we can see it tomorrow. We'll have to do when we do the 12th unit, we'll come with the 11th unit and then go to the 12th unit. Okay? Is it okay?
Okay, sir.
Yes, sir.